So now that we have some experience with understanding what an absolute value equation looks like and how to solve it, we're now going to take that knowledge and we're going to apply it to what it would look like if we were to graph the absolute value function. So first, let's identify what the parent function is for an absolute value function. The parent function is the standard graph or standard function if we have not made any adjustments to the graph. So assuming that everything really equals 1. We put it in function notation, f of x, and we basically just say that the function, the absolute value function is just the absolute value of x. So this, if we were to graph it, here's our y, here's our x. It's just a V-shaped graph that hits every point up 1 over 1. So basically a slope of -1 here and a slope of +1 on this side. This is what the parent function for an absolute value function looks like. It's really important to make sure you understand this because you're going to figure out what changes when we change the equation for the function, how that changes the graph. And we're always going to compare it to the parent function to identify those changes. So let's define the absolute value function. Here is the function notation, and the parent function means that this is the original form of the function. Every function has a parent function. This is the parent function for absolute value. Next, let's look at the way that it's written when we have the full components that are going to allow us to shift the way the parent function looks. So in this case, we're still using f of x. And now we're going to see what looks like a lot of the equations that we were looking at when we were solving, where we had absolute value expression, we had a multiplier on the outside, and we had a plus or minus on the other side. This is the form for an absolute value equation, and we're going to look at what these variables mean and how they would shift the graph, comparing it always to the parent function. It's important to know that we're going to review this. The domain of a parent function, remember domain is the x values. Domain, since we can put any value in for x, any value, that means that it's all real numbers. So the domain is going to be -infinity to +infinity. That means all real numbers. The range is our y values. And if we look at the graph, we can see that there's a constraint here. The y values are never going to be less than 0 in the parent function. So that means the range is going to be 0 is the lowest. And then these lines go forever, so then we have infinity is for the maximum. Okay, so the range is looking vertically at your graph. It's not going to be any lower than 0 because the vertex is there, and it's going to extend up any number for the height. Now, let's also identify this. This is called the vertex, and you just heard me say it. The vertex is where the two lines meet, where they connect. In this case, in the parent function, the vertex is at the origin, and it always will be in the parent function for the absolute value equation. This can change as we give different values to a, h, and k. So Another thing to notice is the vertex is the point h comma k. So when we're given values, you can easily identify the vertex by looking at h and k and writing them as the ordered pair. That's where the two lines of your absolute value graph will meet. Notice that this original form for absolute value has the difference between x and h. This is, remember, absolute value is distance, so it's going to be automatic subtraction. Just like in point slope form, if it's subtraction, but it's been changed to addition, that tells us that this was a negative value. So we'll explore more of that as we keep on going. Let's look at an example of where we change these. And then I'm going to have you explore this and see what you come up with. So let's now say that we put a -2 in here for A. The x stays the same. And then we have -3 plus 4. A is -2. H is +3 because the subtraction symbol's still there. And then K is +4. Now, what I want you to do is go into Desmos, and I want you to put this equation in. Use the keyboard to get the algebraic notation for absolute value. Put it in there. I also want you to put in the parent function, so this one, into the second line. And I want you to compare these. It'll graph both. I want you to identify where do you see the changes that the -2 did? What did it do? What did the 3 do? What did the 4 do? And you might want to do one at a time to see how it's changing. So you can just put in, if you want to do the -2, the rest is the same with H and K. And then, so you can use this, but then just change one of them at a time. But I want you to see what you notice, what you wonder about how these values changed the way the parent graph, the parent function looked. How did it change from the parent function?